Hello students, welcome to Memoneet. I am Sakti Swarup, teacher of Memoneet. I am here to start with a new lecture on electrostatics, that is electric dipole. So before I go to the lecture, I just want to remind you that if you have not bought the BTS test series, please do buy, because I am teaching according to that way only, okay? According to the BTS. So if you appear the test and do the regular videos and also the regular tasks, then you will see your preparation level will be so smooth. At the end of the year you can feel that yes, you have done something great, okay? एंड आपको तो पता होगा कल प्रोविजनल आंसर शीट भी आया है, और 3-4 दिन में क्या पता निकल सकता है, द फाइनल आंसर शीट निकल के वो रिजल्ट भी निकल सकता है. सो दिस विल हैपन इन द नेक्स्ट ईयर ऑल्सो विथ यू. सो बी रेडी फॉर दैट. और मैं तो चाहता हूँ जो भी सीरियसली प्रिपेयर कर रहा है उसको रिजल्ट हो ही जाए, उसको अपना डिजायर्ड कॉलेज मिल ही जाए. ओके, सो let's bounce back to our chapter, sorry, bounce back to our topic, that is on electric dipole. If two point charges equal in magnitude q and opposite in sign separated by a distance such that the distance of the field point r is greater than a, the system is called dipole. So what does it mean? Let's say we have a positive charge here q and a negative charge here is another minus q. Okay, so this is separated by distance, small distance, that is a. Okay, this a is small distance. Okay, and we are comparing to which distance? The distance which is the value, that is distance which is much more greater than a. Okay, let's say it is r, and r is the distance from the center of this system to point p, let's say. Okay, so here this setup is known as dipole, and the electric dipole moment is defined as a vector quantity having magnitude p is equals to q into a, and the direction from negative charge to the positive charge. Okay, so we know that the electric dipole, that is p vector, is equals to electric dipole. Okay, and the value is equals to p is equals to q into a. Okay, q is the charge here and a is the distance between the two charges. Okay, this is the dipole moment, and it is a vector quantity, and the direction, what will be its direction? From the negative charge to the positive charge. Plus दो charges है, 2q and here is minus 2q, and उनके बीच में distance कुछ है say 5 centimeter. Okay, so what will be the dipole moment? Not 5 centimeter, let's say it is 5 millimeter, that is 0.005 meter. Okay, so what will be the dipole moment? So we can write 2q p is equals to 2q into 0.005 meter, and it is in which direction? If it is in x direction, let's say we have here the y axis and this is the x axis. Okay, so this will be in which direction? This will be in minus I cap. Why? We have told that is the direction which will be taken from negative charge to the positive charge. So it is in which direction? Negative charge to positive charge. So this will be in minus I cap, as it goes from the x to towards the negative. Okay, so let's say another example here. We have here, this is y axis, and this is x axis. Okay, and we have three charges. Let's say this is 2q and this is q minus q, and this is also minus q. Okay, so what will be the dipole moment here? So what you will do, let's divide 2q into q and q, plus q and plus q. So there is two dipole here, that is plus q with minus q here, and another dipole, that is another plus q with minus q. But the direction will be what? So direction will be from negative to positive, that is in this direction, and here from the negative to positive, that is in direction. Okay, so the final answer will be the dipole one is here and another one is here, and the resultant dipole is dipole vector will be this, and this is what, let's say it is a distance between the two charges. So under root 2 q a, this is the magnitude. So if we will write according to the vector, what we will write, we will write this component and this component. So what we will write, q a minus I cap plus q into a minus j cap. Okay, this will be the vector, dipole moment vector. Okay, so this is how we can solve these dipole moment questions. Intensity due to dipole at the axial point. Let's say we have here the positive charge and here another negative charge, and it is separated by distance some a. Okay, so what is axial point? Axial point is the point which is present in the line joining between the two charges, or present on its own axis. This is the axis of the positive and negative charge, where these two are present on the same line, and this will be the axial point P. Let's say here the O is also in the axial point, R is also in the axial point. So we have to find out the electric field in P. Okay, so the formula here is electric field is equals to, let's say it is Q and it is Q. Okay, 2 K, and the distance from the center of the dipole to the point P is R. Okay, this is R. So this is 2k P vector upon R Q. Okay, so this is the expression for the electric field for the axial point. Field at perpendicular bisector, that is equatorial position. Let's say we have positive charge here and another negative charge here, and this is separated by distance a. Okay, so we equatorial position, it means perpendicular bisector position. If we draw perpendicular bisector to these two charges, then it will be present in this line. Okay, and this is a upon 2, this is also a upon 2, and here we have to find out the value, okay, in the P. So this distance is perpendicular, distance is R. So the electric field will be equals to P vector is equals to 2 K, it is K P upon RQ, P vector upon RQ. So if you want to find out the direction here, okay, so the at the point P, the negative charge will attract in this direction, and the positive charge will repel in this direction. Okay, so the net electric field will be along plus I cap. It is along plus I cap. Let's say we have another question. Let's say it is positive charge. Sorry, it is negative charge. Okay, this is negative charge and this is positive charge here, and we have to find out electric field at this point, which the distance from the perpendicular bisector, that is R. So we have electric field E is equals to K P vector upon RQ, and it will be in which direction? Let's analyze. The negative charge will attract in this direction, positive charge will repel in this direction, so the net electric field will be along minus of I cap. Okay, so any general point, let's say we have positive charge here and negative charge here, it is separated from separated with distance a. Okay, we have to find out the electric field at this point, any arbitrary point. Okay, let's say this is point P, and we have to find out the electric field here. So so the P vector from the center, okay, sorry, the point P from the center, let's say it is situated r distance away, and this is angle theta. Okay, so we have the dipole moment. Okay, the direction of the dipole moment, we know that it is from the negative charge to the positive charge. This is q and this is q minus q. Okay, it is from negative to the positive charge. So this is our p vector. So now let's say we'll arrange in such a way that, okay, this vector, this p vector will arrange in such a way that then this point will have the axial position and also equatorial position. So how we'll arrange? Let's take the component of this vector. Okay, so we'll make the component of this vector. Let's say this is our one component which will have the equatorial line, and this will have is the another component it will have the axial line. Okay, so this will have the axial position and this will have the equatorial position. बस क्या करना है, इस वेक्टर को आपको ऐसे कंपोनेंट में तोड़ना है so that this point will have the axial and the equatorial line. Okay, this point will present in the axial and the equatorial line. Okay, so हमें easy हो जाएगा interpret करने में. Okay, so for the axial we can write 2k p vector upon r cube, but इधर हम p vector नहीं लिख सकते ना, we can't write p vector. So what we can write, this is theta, so this will be, it is along the theta, so this vector will be p vector cos theta. Okay, इसको अगर हम रिजल्व करेंगे तो this vector will be p cos theta and this vector will be p vector sin theta. So the axial line, what is present in the axial line, that is p cos theta. So we can write 2p cos theta upon rq. This is E axial, electric field axial, and if you will write the electric field equatorial, okay, this will be equals to 2kp vector sin theta upon rq. Okay, एक ऐसा प्लेन है. Okay, this is the vector, that is p vector, and we have to find out the electric field at this point. So what we will do, we have to resolve it into two vectors. This p vector we will resolve it into two vectors along this line and one in along this line. This will be let's say it is present in theta. Okay, this will be p cos theta and this is p sin theta. Okay, so what we can write, e vector is equals to what is present in the axial line. In the axial line the p cos theta is present. We can write 2k p cos theta upon r, okay, upon r cube. But what about the direction here? Okay, we can write what the direction is. The direction is seen with the positive and negative charges. Okay, according to the positive and negative charges, here it will be the negative charge, as we know that the direction is from negative to positive in the dipole moment. Here is the positive charge. Okay, so the present closer to the point, this point p. Okay, so this positive charge is closer, so it will have the repulsion effect, and the negative charge will have the attraction effect here. But the positive charge will have the greater value for the force as it is present closer to the point p. So we can write the direction is along the plus I cap direction. Okay, and that too for the equatorial position. This is the equatorial position for this dipole, that is p sin theta. We have k p vector sin theta upon r cube. Okay, so what will be the direction? So this is negative charge and this is positive charge here. So the negative charge will attract, and the positive charge, what it will do, the positive charge will repel, that is in this direction. So the net electric field will along the downward direction, that is minus of z cap. Okay, this is how we can find the electric field. We will find here here the negative charge in this negative charge is here and positive charge is here. So the net electric field due to the axial will be in this side, and for the equatorial, here the negative charge, here the positive charge. So the negative charge will attract and positive charge will repel. So the net electric field due to the equatorial will be present in this side. Okay, so the net electric field, what it will be in which direction? Along this direction. Let's say this is the angle alpha. So what we can write, this is the equatorial vector, equatorial electric field. This is the axial electric field. Okay, so tan alpha, we can write it as electric field vector due to the equatorial upon electric field due to the axial. So tan alpha is equals to kp vector upon rq upon 2 kp vector. This is kp vector sine theta upon rq, and this is 2 kp rq into cos theta. So tan alpha is equals to sine theta upon cos theta, that is tan theta upon 2. Okay, so the relation, that is tan alpha is equals to tan theta upon 2. So what is theta? Theta is the here. Okay, and alpha it is this. Okay, so the relation between this is important note, please follow this. Okay, have a point out, tan alpha is equals to tan theta upon 2. Right, as E net. E net we have not discussed here. Also the electric field, net electric field will be the square of these two components. Okay, that is Pythagoras theorem. According to the the addition sum of the vector, this is present 90 degree. Okay, their angle between them is 90 degrees, so cos 90 will be 0. So what we can write, E axial square plus E equatorial square under root. Okay, this we can write net, E net vector is equals to kp upon rq, that is taken common, under root of what is 2 cos theta square plus sine theta square. Okay, so we can write kp upon rq under root of 4 cos square theta plus sine square theta. We know that cos square theta plus sine square theta is 1. Let's take 1 cos theta to outside. So we have kp upon rq under root of 3 cos square theta plus cos square, another cos square theta will be here, cos square theta plus sine square theta will be 1. So this will be the net electric field, E net. Okay, so this will be our another formula. Due to small dipole, so potential we can write potential at axial position, that is positive charge here, negative charge is here, and it is separated by distance a, and this we have to find out the potential at some distance r from the center of the dipole. So here it is P. Okay, we can write the potential V is equals to k P upon r square. Okay, real position, we have positive charge here and negative charge here. Here it is interesting because let's say it is separated with distance a, and this is the bisector region, and we have to find out the potential here. Okay, so the distance from the positive charge and the distance from the negative charge is equal. So what we will write, from the any point charge we are writing, that is kq upon r. Okay, and we have the same value for the negative charge, so the potential will become one for the positive and one for the negative with the same value. Okay, same magnitude but opposite, negative in sign, one opposite in sign. Okay, so the electric potential for the dipole at the equatorial position will be 0. V is equals to 0 for the equatorial position. Equatorial position. Okay. Point. Let's say we have positive charge here and negative charge here, and we have to find out the potential at any point. Let's say this point is P, and it is r distance away from the center of the dipole. Okay, so we have to find out the potential here. The uh, dipole direction will be from the negative to positive. Let's say we will arrange it as the component will be arranged as for the equatorial and axial position. It is for the equatorial position, and this is for the axial position. So for the equatorial position, we know that potential V, sorry, axial position, we know that potential is V is equals to K P. This is, let's say it is theta. So this will be P cos theta. Okay, this is P, and this vector is P, and this vector will be cos theta, and this vector will be P sin theta. Okay, so K P cos theta upon R square, and what will be the equatorial, for the equatorial position it will be 0. So V net is equals to K P cos theta upon R square. Okay. Uniform electric field. Let's say we have uniform electric field here. Okay, and we are placing a dipole here. It is negative charge and it is positive charge. Okay, so when and this distance is a. Okay, when we will tilt the positive charge here, let's say we are tilting the positive charge in this direction, and the negative charge will come in this direction. What will happen? The electric field is from positive to the negative. Okay, so here is the positive charge, and the negative charge will attract, so it will have force in this direction, and here uh, the electric field is given from the leftward to rightwards. It means the positive charge is here and the negative charge is here, so positive charge will attract the negative charge, and it will have force in this direction. So the dipole will come to its original position. So this dipole is in stable equilibrium. Let's take another example. हमारे पास लेट्स से हमारे पास ये यूनिफॉर्म इलेक्ट्रिक फील्ड है, और यहाँ नेगेटिव चार्ज है, यहाँ पॉजिटिव चार्ज. ओके, दिस विल हैव नेगेटिव चार्ज एंड दिस इज पॉजिटिव चार्ज. सो द electric field comes from the positive source to the negative source. So when we will make a small displacement of the negative charge here, sorry, small displacement for the negative charge, and the positive charge will come here. Okay, so the force will be generated in the negative charge will be in this direction, and the force in the positive charge will be in this direction. So on small displacement, what it is happening, it will rotate. Okay, on small displacement the system will rotate, so it is in unstable equilibrium, as it doesn't comes back to its original position. Okay, on small displacement it doesn't come back to its original position. Dipole is placed at some angle from E. Okay, let's say we have uniform electric field here, and the dipole is present here at some angle. It is negative charge, it is positive charge, and this is angle theta. Okay, so here from the negative to positive charge, the dipole moment, it is like this way. Okay, so we have here the force will be in this direction, and for the positive charge force will be in this direction. Okay, so this will generate the torque over here, because this is rotating, so we can write tau is equals to uh, in general we know that tau is equals to r cross l. So here in the electrostatic we know that tau is equals to p vector cross e vector, that is dipole moment cross electric cross vector with the electric field. So tau magnitude we can write Pe sin theta. Okay, so this is how we can find out the torque for the given dipole. a dipole placed in the uniform electric field. Okay, so we know that the potential energy, in the previous lecture I have taught you that the potential, what is potential energy, that is potential energy UB minus UA is equals to work done work done by the external agent, that is will be equals to minus of work done by the electrostatic force or conservative force. Okay, electrostatic force or conservative rotating, what we can write, ub minus ua is equals to integration of, we have done that work done is equals to f dot ds. So in the rotating system we can write tau dot d theta. Okay, so tau is p e sine theta dot d theta. So we can write minus of sorry p e cos theta. Okay, so here the this tau is for which force, this is for electrostatic force. So we can write here as negative. So this is minus of p sine theta d theta and this is minus of p cos theta. So ub minus ua, that is change in potential energy, is equals to minus of pe cos theta. Take at the initial condition, the angle between the electric field and the dipole is the 90 degree. So we take it as ub is equals to, or u is equals to minus of p cos theta, because at the initial condition u is 0, because it have angle 90 degree uh, with the electric field. Okay, the dipole have 90 degree angle with the electric field. So we can write u is equals to minus of p cos theta. Just left out, that is we know that tau is equals to p e sine theta. Okay, p e sine theta. So for the small angle we can write tau is equals to p e theta. Okay, so have electric field here. Okay, and here is the dipole, this is positive and this is negative, and the positive will experience the force in which direction, the positive will experience the force in this direction, and the will negative charge will experience the force in this direction. Sorry, it is positive charge. Okay, the positive charge will experience force in this direction. So what it will do, it will try to rotate for the small angle theta. Okay, so this setup is not giving it to be rotated because of the restoring force. So the force we can write it as f is equals to for the restoring force we can write it as, it is not having the proper rotation. What it have, it is this positive charge is not having the proper rotation when we slightly displace it. This is for what reason, this is for the restoring force reason. Okay, so f is equals to minus of kx, we know that. Okay, likewise we can write the tau is equals to minus of pe sine theta. Okay, so this will be equals to minus of pe when the theta angle is very small. So we can replace sine theta into theta, so minus of p into theta. So this is tau, and tau we know that tau is equals to I into omega, that is equals to minus of p into theta. So the value of theta, it is alpha, not omega, is I into alpha is equals to minus of p into theta. So we can write alpha is equals to minus of pe upon I into theta. Okay, so this will be what it is, omega square. Okay, so the value of omega is equals to under root of pe upon I. So we know that time period is equals to 2 pi upon omega, so that is equals to 2 pi under root of I upon pe. The values here, that is 2 pi under root let's say this is L by 2 and this is also L by 2, and this have mass m and this have mass m. So what will be its moment of inertia? M L square upon 4 plus m L square upon 4. Inertia is equals to, that is I is equals to 2 ml square upon 4, that is ml square upon 2. So this is equals to ml square upon 2 upon p. What is p? P is equals to q into l, charge into the distance of separation, q l p. So what it will be is equals to 2 pi under root of ml square upon 2 q l p. So this is how we can find out the time period of rotation. Today's lecture. So have a great day. Make question of this lecture and get prepared for the next lecture. Okay. Thank you.